Hi, and welcome to my presentation. I'd like to start by saying I'm in no way affiliated with Apple or any of the products they sell, nor am I speaking on behalf of any person or institution. Also, I'd like to preface that I'm filming this in my office space with the equipment available to me. So please have the patience if there are any audio artifacts or video stumbles. I'm studying to be a teacher, not a video editor. Today, I'd like to talk to you about resources and strategies to help Australian students currently at the Year 3 level. They both work in a constructivist way, which very briefly means that they use new information to construct upon prior information. Firstly, let's look at content descriptor, measure, order, and compare objects using familiar metric units of length, mass, and capacity. We are particularly focusing on length and how a common ICT tool can help enhance and visualize this skill for the students. I want to bring your attention now to the humble Coke can. Zero sugar, by the way. It's meant to be killing you slowly, but that's a hotly debated. Anyway, moving on. This is not just your typical iPhone video. Here I am using Apple's measurement app, which comes pre-installed onto every Apple device. The app uses its camera lenses and augmented reality or AR technology to interpret the measurement of 3D objects. This app is my first resource for which I would like to make a case within the Australian classroom. By now, most students should be familiar with standard units of measurement, such as blocks, coins, hands, etc. Students should also have some familiarity dealing with measurements outside of school or in other subjects like arts, cooking, or music. Another example of this is going for long trips with the family and using an app like Google Maps or Apple Maps to measure in units of kilometers and meters, except this is very contextual and not every kid will have access to this or be exposed to it. This often has to do with how the students in a social circle views mathematical topics and the type of language they use towards math concepts. It also has lots to do with the parent or guardian's confidence with mathematics and how they were taught in school. This is where the teacher's role of it and adherence to the teacher's standard of knowing the student and how they learn comes into play. Now, moving on to the app again, because I know you've been dying to see it, I just want to show you a few examples of me using it and how I imagine it can be integrated into the classroom and even extended upon using free software. See here me comparing the two 3D objects to one another and then taking screenshots throughout. The iPad gives out a reading that adjusts to how I move and uses the metric system's unit of measurement. You may be asking yourself, well, how does the app fare with bigger objects? Behold my gait. The truth is, it doesn't fare well. The bigger objects have wildly inaccurate readings. As you can see here, it says my gait is about 138 centimeters, when in actual fact it is precisely 180 centimeters. However, the small items, such as the Coke can, were only off by about 1 centimeter. So, how can I use this in my classroom in an engaging way? Let's start with an engaging hook or start to a measurement lesson. The measurement app could be used to live broadcast to a smart whiteboard using Apple's screen mirroring software, and one person in the class could volunteer to be the holder of the iPad. While looking at the screen, the class could collaboratively make estimations on height or width of an object within the classroom. Once the estimations are in and written on the board, the student with the iPad could use the app to measure the object. After that, a second student could use a measuring tape to confirm or contradict the iPad's measurement. This activity involves the whole class, engages all learners, uses estimation skills, which are vital for fluency in measurement, uses investigation and problem-solving skills, and also the use of ICT in a meaningful way. Another thing about this resource is that it is now commonplace for iPads to be within the classroom. When in the digital space, everything can be captured and stored. This allows for students to add video with measurements to presentations and project-based lessons, just like I have in this presentation. I want to demonstrate an idea for extension using the Numbers app within the iPad in correlation with the Measurement app. See here how you can use screenshots taken from the Measurement app and place them into a spreadsheet. From here, a student could create a comparison sheet for items in the classroom and order them from shortest to longest, or whatever you choose. Maybe the wingspan of each student, for an example. Furthermore, research suggests that the use of iPads increase engagement in the lesson, along with a wealth of evidence that state concrete and hands-on experience promote learning. The 21st century learner likes engaging in tech, especially when it can interact with the environment around them. The measurement app is also extremely visual and combines real-world concrete materials with often challenging to grasp symbols associated with mathematics. This could help a struggling child that is failing to move from the pictorial stage to the symbolic one by way of combination of both. A common misconception students have when first dealing with measurement is the conversion of units. Students may find it hard to understand why a smaller unit has 2 letters, centimeters, cm, when a bigger unit only has 1, meters, m, falsely assuming meters are smaller than centimeters or millimeters. The measurement app is a great tool to help children understand the measurement units in real time, using real objects in front of them. Take a look now at how the app could be used to demonstrate this to a student, especially in a one-on-one or even better, peer teaching situation. I'd now like to move on to our second resource being demonstrated today. It is extremely simple, yet when paired with 3 activities I will explain, it gives students a great understanding of the 60 seconds that make a minute. Firstly, looking at the content descriptor in question, tell time to the minute and investigate the relationship between units of time, with the elaboration of recognizing there are 60 minutes in an hour and 60 seconds in a minute. Did I say that right? Recognizing there are 60 minutes in an hour and 60 seconds in a minute. This is still within the Year 3 level. The resource I'm vouching for today is the Humble Stopwatch. I'm being a little dishonest when saying I'm vouching for the stopwatch, when in fact I'm vouching for the stopwatch in tandem with the activities a quiet minute, a busy minute, an active minute, and a counting minute. Let me explain further. The passing of minutes on digital or analog clocks is the first time students will meet the idea of base 60. That being 60 seconds equals 1 minute and 60 minutes equals 1 hour. Working with a minute as a standard unit is a good place to start. By Year 3, the majority of students will know what a minute is. However, they might not have a full understanding of 60 seconds making up a minute. It is important for students to recognize this before moving on to telling the time to the minute. I'm now going to explain how these exercises work. Firstly, the quiet minute. By either placing a stopwatch on the interactive whiteboard or pairing off the students, have them close their eyes. The goal is for students to close their eyes and only open them once they think an exact minute has passed. Once they open their eyes, they should write down the time on the whiteboard. After every student has opened their eyes, discuss their findings and compare results. An active minute is when you have a student pick an activity, like say jumping jacks, and again, only stop once they believe a minute has passed. Again, write down the time they stopped and discuss. A busy minute is when a student should repeatedly draw a text or picture and only stop once a minute has passed. And again, you guessed it, write it down when you stopped and discuss. Lastly, a counting minute is when the students use beads or counters to count out the minute, stopping once they believe the minute has passed. These activities can be done consecutively or spread throughout the unit. From each activity, you can have a discussion afterwards and see who got the closest to the minute. Ask questions like, when did time move slowest for you? Or, when did time fly? This is a very inexpensive resource and can be participated by everyone, even if their concept of time is not very strong. In fact, with a task such as this involving their peers, they are more likely to grasp the concept of base 60. Regarding the curriculum key ideas, this resource and activities allows for a connection between the previously exposed concepts, like the minute and now the specifics within a minute. They use their ability to make estimations throughout and gain an understanding on how to measure a minute with or without a clock. Students also get to justify and discuss their reasoning behind their interpretations of a minute and why time can be cognitively perceived in different ways depending on set and setting. Regarding barriers to learning, children are often exposed to units of time they don't understand. Things like, wait a minute, or grandma will be here in an hour. Often these concepts will develop naturally, but not for all. It's important when entering the topic of time that students have the foundational knowledge of what a minute is, and by doing a short class activity such as the ones mentioned above, the child with the misconception of a minute will likely form a new connection. This activity also has a secondary benefit of showing students their perception of time, which could be particularly relevant for students with attention deficit hyperactivity disorder. The latest statistics show that 10% of all children now have a form of ADHD. Also, students with ADHD have poor time perception, and studies have found that people with ADHD also, unsurprisingly, have poor time management skills when not engaged. There is some great research that shows that visual focus tasks that last as short as a minute, such as the busy minute, drastically improve focus within the lesson. This can also be as simple as looking at your hand for a minute. Interestingly, the exercises are even more effective if the students can withhold blinking. Briefly, the reason behind this has to do with dopamine, and surprisingly, dopamine is linked to the rate at which you blink. Students with ADHD have a lack of baseline dopamine and therefore find it hard to focus and seek more stimulating activities often. A minute exercise could help with not only reaching students who haven't grasped the concept of a minute, but also improve the focus of students for the remainder of the lesson. Just as a caveat before I finish, the visual focus task worked best after exercise of some sort, so it would be best done after a break time like recess or lunch. Finally, I'd like to thank you for your time. I hope you've enjoyed my presentation. Linked with this is the justification with references used for the findings within this talk. Have a great day.